Right, this is BTEC Engineering, Unit 7. We're currently on B12, on page 12 of the Section B examples. As usual, this is a video, not a lesson, so I won't be pausing for you to take notes. You will need to pause to take your own notes. So we're on page 12, which is this. So we're to use the mid-ordinate rule with 4 strips to find out how far the vehicle has been travelling in 4 seconds, given that v equals t squared minus 2t plus 3. Explaining your method is how you get your merits and distinctions. Calculating what they've asked you to is what you need to do just to pass. Right, so first of all, mid-ordinate rule is a method for estimating the area under a curve. So if you have a curve, basically we work out a series of rectangles, and the estimate of the area under the curve, you add up all the areas of the rectangles. That's the principle behind the mid-ordinate rule. Now, to do this sort of work previously in the section, we've been using definite integration. Well, definite integration corresponds to an area under a curve. So we're going to use this method to estimate answers. So first of all, we need to draw a table, but before we can do the table, we need to know what the strip widths are. So the strip width will be how long we're going to be travelling, the 4 seconds, divided by how many strips we're going to have, how many rectangles. So 4 divided by 4 is equal to 1. So that all the rectangles will have a width of 1. So if I was drawing it, it starts at 0, 1, 2, 3, 4. 4 rectangles going upwards. However, the mid-ordinate rule uses midpoints to work out what the height of the rectangles should be. So the midpoints here would be 0.5, 1.5, 2.5 and 3.5. So those middles will basically tell us how high each of the rectangles will be. So I need a table. So T and V. I'm going to start at, I need to find out V for each of those T values. So we need to, the best way to do that is to use the table mode in the calculator, the same way that we did way back in section A for doing plotting graphs. So if we do mode 7 for table mode on the silver calculators, different number for the black calculators, we get f of x equals, we need to type in, we've got our for in terms of t, we have to use x for the calculator, so we put in x squared minus 2x plus 3 into the calculator for f of x equals, and as a reminder, to put the x in, we press alpha, close bracket, and that will put an x in. Then, if you put in the equation press equals, it asks us where do we start? Well, our table starts at 0.5, so we type 0.5 in equals. Then asks where does our table end? Well, our table ends at 3.5, so we press 3.5 equals. And the step, it's going up in 1. So we press 1 equals. And we get an exact table to fill in. So we've got 2.25, 2.25, 4.25, scrolling down, 8.25. Now the mid-ordinate rule, there's a formula, so a quick way of adding up all the rectangles is the strip width times, open bracket, the sum of the V. So the strip width here is simply 1 open brackets, for the 1 from here, and then we add up each of these v values, 2.25 plus 2.25 plus 4.25 plus 8.25. And then we calculate that. So, put in the calculator, mode 1 to go back to normal mode. Stick it in, 2.5 plus 2.25, 2.25 plus 2.25 plus 4.25 plus 8.25. There was 1 times at the front, but that didn't have any impact. Add them all up, we get an estimate of 17 for the area. And that's the mid-ordinate rule, so that's part A. Moving on to part B is a different numerical method. So instead of using rectangles to estimate the area, we use a series of trapeziums instead. So from the points we join them up, and so on. So that's the basis of that numerical method. But we'll need a new table, because instead of using the midpoints, we'll actually need the values at the edges of the strips. So the strip width is still the same, it's still equal to 1, but our t values, and therefore the v values, will be different. So we'll start at 0 and go up in 1s, up to 4. So we need to go back to table mode. So mode 7, stick in the formula for f of x, same as before, x squared minus 2x plus 3. But now we'll have different start and end values. The step value is still going up in 1s, so the step value will still be the same. So let's repeat that process. Mode 7, stick in the formula, alpha x squared minus 2 alpha x plus 3. Start, well, the start of our table is now 0, so we're now starting at 0. The end of our table is now 4, so 4 equals, but the step is still the same, so 1 equals. And we get a new table, so 0 is 3, 1 is 2, 2 is 3, 3 is 6, and 4 is 11. And again we have a formula that allows us to do the trapezium rule. So instead of working out the area of each individual trapezium, we just instead apply a formula. So the formula is basically strip width divided by 2, open bracket, first plus last b. So first b plus last b plus 2 times the rest of the b. So what does that mean? Well, in this case, the strip width is 1, so 1 over 2 at the front. The first v is the one corresponding to 0, so 3. Plus the last v, corresponding to the 4, is the 11. Plus 2 times the rest of the v, so the 2, the 3 and the 6. So we need to calculate that. Mode 1, to go back to normal mode. So we put half, open bracket, 3 plus 11 plus 2, open a second bracket, 2 plus 3 plus 6, close both brackets, equals 18. So our first estimate was 17. And our second estimate is 18. And that's 2 of the numerical methods that we're going to use. So moving on to part C, which is the Simpson's rule. Now, we use the same table as trapezium rule for Simpson's rule. Simpson's rule is a way of taking several different methods of estimating the area and then combining them to make a better estimate. So it doesn't just correspond to a shape like the mid-ordinate rule or trapezium rule. It's basically a formula that combines several. So Simpson's rule equals the strip width over 3 times, open brackets, first V plus last V plus 4 times the even V, I'll explain what I mean by that in a minute, plus 2 times the odd V. Now, when we're using that formula, when we talk about the even V and the odd V, it's not about the actual numbers themselves, but their position. So that's the first, I should say, the rest of the odd. We don't pick anything that we've used before. So that's the first, that's the second, that's the third, that's the fourth, and that's the fifth. So sticking in the values, the strip width is 1. We divide by 3, open bracket, first V plus last V, so first 3 plus 11, plus 4 times, open bracket, the even V. So the even ones correspond to 2 and 4. Position, so the 2 plus the 6, close bracket, plus 2 times the rest of the odd V. So we don't include the first and last because we've already used those. So the only remaining odd one is the 3. And close our brackets. And then stick all that into a calculator. So 1 over 3, open bracket, 3 plus 11, plus 4 times 2 plus 6, close bracket, plus 2 times 3, close brackets. We get as an estimate 17.333 to 3 decimal places. And that's Simpson's rule. So you have to do the numerical integration in 3 different ways for 3 different estimates. And in order to get the higher grades, the merits and distinctions, one of the things you have to do is to compare your answers with those that's obtained in B5. Now B5 is a precise exact answer, so that's the first comment you really should be making. The answer obtained using integration gave me an exact answer. Then I would look at my 3 answers for part A, B and C, and if, say, the Simpson's rule was the best, I would say Simpson's rule gave you the best estimate as it was the closest to the true answer, followed by next best one out of trapezium mid-ordinate, and the worst answer was given by, again, which was the furthest away from mid-ordinate or trapezium rule. If you don't do that, you won't be able to get merits or distinctions on this unit. Best of luck.